Hello everyone, welcome to another stream. Hi there, we're working in the... there's no one here. Hold on, did I paste in the link into Discord? I did, I even got a Miku GIF in response. So, hi there everyone. How are you all doing? I don't think anyone's watching it. Or maybe it's my YouTube bugging, I don't know. Let me see. No. I'm just alone. Anyhow. Hold on, let me first start by chugging some coffee. Okay, so here's the idea for the day. Yesterday, we kind of gone ahead, I still have it open by the way. Yesterday, we kind of gone ahead and designed a processor. Because, I don't know, kind of... We went off script yesterday, and so, long story short, I'm making a completely new video that I didn't really have planned, but I kind of made the most difficult part of that video. Well, I imagine the most difficult. It's a processor, so I fingers crossed, man, right? This would normally connect to addresses and memory, but that don't really matter. So, all we're gonna do today is just script and hopefully set up geometry nodes in Blender for the animations for the video. And note that I would first prefer to not finish the script, because, you know, I can't just finish the script in a single setting on live stream. That would be... Well, I could try to finish the script in a single setting on a single live stream, but you know. So... We'll just work on the script. Simple as it could be. So register. I'm glad, you know what, no one... Oh, hide the QWERTY. I was about to say that no one's watching, so it's a perfect time for me to script, but hide the QWERTY, I suppose. Hide. Yeah. Yesterday we went a bit off script and designed a processor, so today I need to work on the video too about that processor. Just some kind of... Oh, wait, I can... So how would we do it? Well, first, how would we do it with a single bit? Or to oversimplify it even more, how could we save a single bit? So how would we make a circuit that takes in an input, and then if that input... Another sip. How are you doing, QWERTY, by the way? How's the day going? And then if that input is on, then it gets saved, and it stays that way even if... Fine, I'm also doing well. Oh, it just hit me. It just hit me that this circuit is actually wrong, innit? Why didn't you all warn me? Because if this turns on, then this also turns on, which it shouldn't. It should only turn on click. Uh-oh, this circuit is wrong. This 1 and 0 shouldn't matter. Shucks. Piss and fudge sticks. Shucks. Hold on. Let me get back to my ancient manuscripts. Basically what we want is 0, 0, don't care. 1, 0, don't care. 0, 1, 0, 1, 1, 1. That's what we want. In which case... This we want to not affect the value. This, however, we want to change the value, which means we want the... Oh, shucks. It just hit me that this is just completely wrong. We were trying to save numbers. So how would we do it? Well, that's a phenomenal question. Yeah, try as well, then it's on the environment, you get hypercolorous acid, and bleach. Yeah, it seems about right. Hold on. Sodium chloride, hypochlorous acid. Wait, electrolyzed water and salt. Is that right? H2O and sodium chloride. You electrolyze it and then you make hydrochloric acid. Shouldn't you get hydrochloric acid, or am I wrong? I guess you're electrolyzing, it might be not. Do you really not get hydrochloric? You get hydrochlorous. Because hydrochlorous acid, is that the really dumb one? Hold on, is that the one that was really dumb? Hydrochlorous. Is that the one that looked like a base, but it's an acid? Hydrochlorous acid. That is the one. This is what the dumbest acid I know. Because it looks like a base. It's so hilarious to me. It looks like a base, but it's an acid. And then you get extra hydrogen and sodium. Is that really what you get when you electrolyze them? I would think you would get hydrochloric acid and sodium hydroxide. I had no idea went this way. Why is it not going for hydrochloric acid? So what you get chlorine gas. Oh, is it because chlorine binds with it to make chlorine? When you electrolyze them, you get sodium hydroxide, hydrogen, and chlorine. Oh, the gas bond is too strong? Is that why? Little water and sodium hydroxide. That's wild. This is the dumbest acid though. I dislike it a lot because it looks like a base and it always confuses me. Anyway, if this is 0 and this is a 1, we don't want it to be edited, which means we don't want it to be... We only want this to affect the value saved. You know, let me actually completely remake this. What we want to happen is we want this to only affect the value saved if this is a 1. Otherwise, you keep doing U, which means we want this to get set to this if this. Which means that I can figure this out. Don't help me, everyone. I haven't slept, by the way, but but that's not why I'm struggling. I'm struggling because I'm an idiot. I have successfully sidetracked the streamer for 5 minutes. I am Vaspera. I would just like to mention that my last sidetrack resulted in these two. This is my last sidetrack. Yesterday I got so sidetracked on stream that I made the processor. Can you make AND gate without AND gates? Well, that's a tricky question, Penguin Boy, because I mean, all of the logic gates are made without using these logic gates from more basic components. You could make it using a MOSFET. I do believe you can treat the MOSFET as an AND gate. Make it. Are you an electronics engineer? No, but computer science is the topic I know the most about. Hence, why this series of videos. This is actually episode 4. Not A plus, not B. What is plus supposed to mean there? Vaspera? This and this. Okay, no, I can figure this out. We don't want this OR gate, that's the issue. We want it to cycle. We want the buffer. Hold on. Yeah, we want a buffer. I don't know if buffer would work actually. I hope it will. We get an error if I turn it on. That's lovely. That's really neat. Okay, can I like that makes sense. Makes sense that we get an error. So we cannot use a buffer. A second buffer, with 2 buffers, you say. That might just work, you know? That might just work. It doesn't. Double the buffers! On the return, like right here as well. You know, I'm just gonna pepper all of it with buffers, because why not? They're free. It is erroring all the time, but that's probably why. No, that is totally not why. Okay, well, I mean, OR gate worked, I suppose. Oh, you mean like right here? I don't mean to be that guy, but no. More buffers! Are you making a register? Yes, I am. Input. So we have value X. We have value X, then we want to keep that value constantly, which would be loop, right? That would be the OR loop that I had going on. Now, if this will be slightly more tricky, but it shouldn't be too much trickier. Which means it should be slightly tricky, but not too tricky, because the loop is, after all, what gives us the loop-de-loop. Does it work this time? It does, okay. Great, so that holds the value. The only problem is it only holds the value if it's a 1. Which is not what we want. We don't want it to hold the value only if it's a 1. We want it to also hold the value if it's 0. Which means we need to somehow find a way to amend it so that if this is a 1 and this is a 0, if this is a 0 and this is a 1, it doesn't change it unless X. Why is this so difficult? We would need another storage bit that tells us if the value is saved currently. What is the game you're playing called? The game is called Logisim. It's open source actually. I would really recommend. It's a great game. Logisim. Yesterday we did a speedrun of it. We did a any percent speedrun. Vaspera, $3. Jeez. Alright, let me add you to the website. Would you like me to call you Vaspera? Would you like me to use that as your name for the website? Is that the fine name? Or would you like me to put something else? Put that in there. Alright. Done and done. Don Hosel. Don Hosel. Okay, I think I spelled that correctly. Amount 3. There we go. Sudo. Okay, now let's see. Let's see. Let's get rid of the lower rows. Where's you at? You are in fact right here. This is your pie chart slice. This is your slice of pie. That's your slice of pie. The name of the thing, slice of pie. That's where the name comes from. The slice of pie. There we go. Now it's done. Now back to not getting sidetracked again. What do we want? The tricky bit is that I can do it asymmetrically. That's easy. It feels like an EXO would walk. It feels like it. It just feels like an EXO would walk. I don't know why I have that feeling that an EXO would just work here. Alright? So basically with an EXO, if we turn it on, nothing happens. It turns on if the first or second. Nadia, oh wait, now that I cannot pronounce. That starts with a letter Y. Okay, well then, what would you like your nickname to be on the website? I'm fine with being prevented from doing work for charity. I can manage. Let me know what would you like your name to be on the website. In the meantime, I'll just think about this. So if we set it to be some kind of value temporarily, right? If we set it to be, let's say, oh, why do you have to be like that? Just don't error. My goodness. It's simple as it could be. Okay. Ah, that's the next now. That's not what we want. We want one. We want a one. We want a one. Perfect. Delete this. Okay, that holds. And then if it chambers. Okay, well, fingers crossed that I don't misspell your name in that case. Nadia. Alright. Y-V-E-T-T-E. I think I spelled that correctly. Chambers. Chambers. I think I did all of that correctly. However, it is euros and my website it's a French name. I can tell. I can sense you French, let's call it people, from a mile away. Honestly, greatest mistake of our lives. Recognizing France as a country. I'm sorry, Nadia. I'm sorry. It's in my. It's just a muscle memory, all right. It's muscle memory. This just happens. I tend to just. I'm not the French. Oh, thank goodness. Never mind. Oh, oof. Dodged the bullet there. Thank you. Thank goodness so much. There we go. Got my password correctly on the first try. I'm practically a hacker. Nadia is Russian, a pretty Slavic name, but I'm not sure neither. So many names then. Hold on. Hi, the timer. There you are, right here. There you are. Now let me turn off Dems.
Switch to live chat.
I already did.
Good.
There we go. That's your slice of pie. Anyhow, back to not getting sidetracked. EXO feels like it would work in this case. If we have a 1, that will turn it off if we have a 1, which is not what we want either, is it? Yeah, exactly. Yeah, an oscillation apparent, and then it's just gonna crash my whole thing, and then I'll have to just, you know, turn it back around again. Why don't and? Because if I and, then it will just turn off right away, which is not gonna work. So this to remove. And we need to think of a better way to do it. What does EXO tell us? EXO tells us only one of them is on. This is tricky. Oh, are you googling that? Come on, Black Thunder, come on. Hi, Detefta. Hi, welcome. How you doing? Hi. How was your day? Oh, thank you so much for asking, Pinguoy. My day was pretty long so far. I haven't done nearly enough work. But hey, that's why this stream is. That's what this stream is here for. If not for the fact that I can't keep getting sidetracked with donations. I suppose getting sidetracked with charity donations, that's a good thing. Can't complain. I can't sleep, so I decided to watch your stream instead of putting some white noise in sleep. I am glad to help in that case, Sebas. Glad to help. Okay.
I adopted that habit too.
Let's think about this reasonably. What we have here is basically... The problem is that we're not picking ones or zeros. We're picking include the input or disregard the input. And that is a lot more tricky. However, it feels like there will be some kind of combination. I have an idea because okay, you know, let's run up. Actually, need to add logic in. Let's see. What are you making? Actually, Tefta, funny story. Yesterday on stream, I was. This is actually a funny story. Hold on, let me open up my. This is actually a pretty funny story. You see, yesterday on, I started the stream wanting to work on this video because I made like 3 little programs. One of them in Python, one of them in C, and one in assembly. That all just calculate the factorial. And I wanted to work on that video, and I started working on that video, and then I was like, damn, the necessary background, it would be actually really convenient if I explained how registers work and how CPUs work. And I just was like, oh yeah, and this thing, and this thing, and that thing. And I just kind of kept going and, you know, just sort of like, I don't know, kind of designed a CPU just on stream. The simple one. It just kind of happened. So yeah. Accidentally.
Sorry, go on.
Yeah.
Accidentally designing the CPU. Yeah, happens to everyone.
I mean, I did. It's fully functional as well. It can, to be fair, it can only multiply and add. It can multiply, add, and save, which is, well, what else do you need? Like another? Well, that's a neat thing. This is basically the reason why I am so happy with it is because this will be good. This will explain how CPUs work so perfectly, because this right here is an 11-bit. Like everything inside is 8-bit, but this is 11-bit input. And what this 11 bits do is you have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. First bit tells you if you are adding or multiplying. Second bit tells you if you are saving into RAM or saving into a register. Third bit tells you if you are saving a number or not. And 8 of these give you the address, either of a register or memory. And as such, you can... Oh, I just heard myself from time and it just spooked me. You can actually write code for this, which is why it's not a calculator, it's a CPU, simple one, as I keep mentioning, but technically a CPU, which means that if I just plug this in, I didn't actually plug in the memory because, well, it's not really necessary for the purposes of the video, but if I just plugged in like this into RAM, and read it line by line, this would be fully capable of simple computation. You could make a program for it. And that's why I think it would be especially neat for a video, because at the end of the video, what I would like to do is I would like to make like a simple equation, something like a plus b times C, something like this. And I would actually like to write out the machine code for it. And I think that once I write out the machine code for it at the end of the video, everyone watching will understand exactly how CPUs are able to compute stuff. And I think that will be the best computer science video I've ever made. But in order to do it, I am missing one thing, which is I need to design my own register. Because if I don't make one, then I won't be able to explain them all that well, and if I won't be able to explain them all that well, then what's the point of the entire video? So yeah, I kind of got sidetracked yesterday. I was drawing the alphabet, so I stick to Nadia. Awesome, yeah. Yeah. Actually, let me test it again, because... So for example, let's say that this is my simulated memory, by the way, because I couldn't be bothered to implement the memory. That's why all of these pins are just, you know, left hanging. But let's say we want to multiply 16 by 3, because why not? Then... These are hex, remember? Yeah, that's what I said, 16 by 3. This is a 16. First, saving 16 into the first register. That is the 0, don't care about operation. Then 1, because we are then 0, because we're saving it from memory. Then 1, because we're saving into the first register. Wait, no. 1 because we're saving it, right? 1, 2, 3, 4, 5, 6, 7. And then 1 because the first register. There we go. If we run it, there we go. Our 10 just got saved into memory. Then, if I do remember correctly, 0 should be the blank. There we go. 0 is the blank, which just resets the circuit. Then 0, 0, 1, 1, 2, 3, 4, 5, 6, 7, 8. Then into the other one, this is our 16. Into the other one, we want to write a 3, like this. Oh, I just did a 0. Right. I forgot about binary. 0, 0, 1, 1, 2, 3, 4, 5, 6, 7, 8. Now if we run it, we can save a 3 into this register. Then to multiply them, what we need to do is first of all run a blank to reset everything. And then in order to multiply them, we want multiplication, then... Oh wait, we already multiplied them by running a blank, right? So now that we've multiplied them, this is our result. We want to save it, for which we use the, we don't care about the operation, we use the from the result, save 1, 2, 3, 4, 5, 6, 7, 1 in binary again. There we go. And now we run it. There we go. We got a result. Isn't that kind of neat? Calculator. The neat part is, the reason why I'm calling it a CPU, by the way, not a calculator, is because what we just did wasn't but pressing buttons. This was code. You could have it in a line, and you could have the clock, which we have right here, just slowly feed in line by line into this register. In which case, this, you could like pre-program it, which I find really neat. Now, obviously, once again, as I mentioned, I didn't really implement the reading from memory, because then I could just like plug this in and feed this into an address, which I'm guessing is A. There we go. I could just feed this into A and this plug in right here. And I mean, actually, I could just do it. just do it right now. But yeah, so that's not the difficult part. To be fair, you cannot really... There aren't really ways to... Well, we only have 2 registers, which is kind of limiting. But I keep getting distracted. That's what happens when I don't sleep at night. Okay, so once again, what kind of circuit do we want here? We want a circuit which x, if x 0, then it outputs... No, we need 3 of them. X, S, 0. If that's the configuration, then it outputs S. If X, S, 1, then it outputs X. That's what we want. And that is actually it. Yeah, that seems much easier. So first input, second input, third input. Let me just reorganize it a bit. Right, this is our resetting input. So. I'm thinking slowly. You're gonna have to be patient with me. How is square root done in binary? I don't remember, to be honest, but there are plenty of methods of approximating difficult operations. Fun fact, one of the first operations I implemented in assembly was a cosine. Simply because you can just approximate it using a Taylor series, which is trivially easy. That's because you don't actually need to calculate some stuff, you just need to approximate them. You know. And then last thing, which will be an S. Which will be right here. There we go. Now, X if 0, this feels like a kind of... Ah, damn it, I keep... No, I need to take it slowly. I don't have the capability for it right now. We have 0, 0, 0 results in 0. Anything with 0 gives us the middle. 0, 1, 0 results in 1. 1, 0, 0 results in 0. And 1, 1, 0 results in 1. Right. Then 1 results in 0, 0, 1, 1 results in 0, 0, 1 results in 1, 1, 1, 1 results in 1. Okay, this feels a lot more. Make it, are you not reading any answers? Yes, I am not reading any answers. In which case, these are just... So the second part will be the first part flipped. Yeah, makes sense actually. As such. My brain keeps coming back to like, oh, if it's a 0, disregard the left. If it's a 1, disregard the right. But you can't disregard make it. Stop thinking this way. I'm getting stuck in a pointless loop of just misery and useless thoughts. By the way, you can make logic circuits using redstone Minecraft. You can make logic circuits using crabs in real life. You can make logic circuits out of anything that has the capability to change. The first episode of the computer science series. I've explained it. I even used the crabs as an example. All you need in order to do logic is a information medium and basic manipulation. And that's it. Once you have those two, you're basically golden. Them undid always rolled in one, but I don't wanna do it this easily, do I? Crisscross always was this. Probably should have run down this way. Sebas, why did you instantly delete your comment? I didn't even get a chance to read it. Okay. So... I made a major spelling mistake. Okay, that's understandable then. You get a pass this one time. Wait, if I and these two, but that's pointless. If I and them with a not, then that fits. If I and these two, that fits. That's a really good start. But now I need to somehow combine them. So we're gonna have x and not. Let's call it tick. Why not? X and not tick, and then we're gonna have s and tick. I did it backwards. This is x is supposed to be tick, and s is supposed to be not tick. But then how do we combine them? Well, we combine them. Let's take a look at this example. For example, we cannot combine them with an or, because 0... Wait, no. 0 and no one, that's it. We can combine these with an or, actually. That's good. What about this? Well, this gives us 0. We can't combine them with an or. Alright. Now, what about this? We cannot combine this with an or, however. And that's a pickle. So how do we combine them indeed? If we or them, it fails right here. Because 0 or 1 gives us a 1, and we want a 0. So we cannot use an or. If we use an and, then it obviously will fail. The same principle. So we need to use something that ideally you can use an or. What do you mean you can use an or? Hold on, let me see for this example right here. This example, that would be 1 and 0, or 0 and... Oh, it's because it's 1 and 0. That tracks actually. Yeah. Yeah. That is fair then. The inverse takes care of that. So this. And then we just loop-to-loop with possibly a resistor trick to solve it from just every single time defaulting to an error. X and T, S and not T. Alright then. OR gate right here. Plug this in. Narrow with just 2 inputs. Then what we want is we want then X and T. So this is our X, this is our T. I am so glad I put them on the opposite side. Okay, let me just reorganize this a bit. X and T, and then S and not T. There we go, and then we just OR them in. And now if we just save, there we go, we collapse it, we have an infinite loop! Where did I mess up? I should have been inversing the tick. I did inverse the tick. Uh-oh. Uh-oh, that's not good. Hold on, let me see. So... Ah! Fuck. Okay. Shit. 101 is our scenario. 101 should result in a 1, which is good. This is the tick. This is the save. This is the... What is happening? The configuration we have is X and T, S and not T, and both of them into an OR gate. And to be more exact, we have 1, 0, not 0, 1. 1 and 0 gives us a 0. 1 and this gives us 1 and 1, which gives us a 1. This gives us a 1, which should give back a 1. This should turn on. Oscillation apparent. Don't be a pussy. Go in. It's not oscillating. What do you mean oscillation apparent? There is no oscillation there. This should turn on. Why is that? I don't understand. Well, it all would seem to be working correctly if not for this oscillation? That is not oscillation. That's not how oscillating works. This is plugged in. I don't know what seems to be the issue though, honestly. I feel like... I don't mean to be that person, but that is not oscillation. That is very much not oscillation. Can I help you make it? I kind of done it. The only issue is I don't know why it's telling the Resident does not enjoy recursive updates. Well, apparently. Hold on, maybe there is like a component for recursiveness. That's possible. You know? I think that's probably what would be happening, like wiring. I imagine you would probably have, or a buffer, I guess. I guess that's what the buffer should be for, isn't it? But if you turn this on, then you turn this on, and then this is still on. What is your problem? I don't understand. Oh wait, what? Sub-circuit appear. Oh, you can. Oh, if it was a sub, that makes sense. Actually, I don't know. I didn't think of that. Oh, oh, you can has. You can have subs. That's actually kind of lovely. This is. I don't want to deal with this. This is ridiculous. I know, pull resistor. Pull resistor will not fix anything. It never. Well, it does fix stuff. Yeah, now it's gonna be a constant 0 and it's gonna crash even easier. How does the transmission gate work? Ah, you're getting sidetracked, make it. Whatever, the point is, it works. It's getting my seal of approval. Oh, is that how you add circuits? That's quite neat. Huh. Anyhow, the point is, congrats, it's done. Which means, I guess we just means we need to script the video. Or we can make the geometry nodes for logic, I suppose. We could go either way. What should we do, everyone? Do Blender geometry nodes for logic or work on the video? I mean, or script the video, of course. Both of these would be working on the video. Both. Fine, I guess.
Barlin's got a point.
Work on the fanboy with you. Functional logic gates in Blender. Functional-ish. It's functional-ish. I know. Okay, so here's the thing. I haven't actually made the geometry nodes for logic in the newest version of Blender. I have them in like a really old one. Memory, and right here, let's call it logic gates. I'm gonna make them in the master folder because they will be useful. And here's the basic idea of how it will function. I'm gonna make the logic gates. So first I'm gonna make a knot. Did I just delete the default cube to other? Yeah, whatever. I'm a Blender user. We can do that. Hi to someone. Hi.
Hi.
Now let's start with a cube. The follow. The goodness come for raging crawlers to take this one apart. Just roll up the follow. So that we live in an open, okay. 6, 5, 5. Or we can just do 5. That seems fine. Okay, and now it's gonna be fun because we want to do it in a smart way. So first, let's start with a knot. We'll set the material to white and we'll store named attribute. Color, and that color will be red. Pure red, yes. Perfect. Then, right here beforehand, we'll have join geometry. And I'm gonna style it based on my old logic gate models. Like this, there we go. And then we basically want 3 of them. Make it 0.45 if I'm not mistaken. Should push it to the edge. Perfect. And then 0.45. Perfection. So we have this so far. Then what we want is 2 cylinders. One on the left, one on the right. However, those cylinders will have their own group right here. With this one being equal and having saturation of like 0.3. Maybe 0.4 if I'm feeling fancy. And then the next one being dry, which will be a float of 1 for now. And then, actually no, this should be... should move this. And then right here we'll have 2 cylinders. So cylinder. That's a bit big. My computer is really loud right now, and I don't know if it's this recursing, because it might be. It has a tendency to just recurse. Discard for now. Buy someone, buy... Alright, now let's see. We don't want it to be black though, so let's do call. There we go, perfect. And we're going to rotate it 90 degrees, move it up. Like this, and move it back. Like this. 45 divided by 2. Perfection. And then just copy it. The same exact thing except with a plus. Perfect. Then we're gonna have them be 2 opposite values. That's because whatever the first value will be, so we're gonna have a value like this, which goes into the first one, and then math. Actually, no, wait, boolean. Let's do boolean. Let's be proper about this. Let's have a boolean. Boolean will go into the first one, and not boolean will go into the second one. And now this operates like a NOT gate. Simple. Neat, convenient, tidy. Sweet. Let's group it all. And then for an output, we want the NOT logic to be our output. And then we want this to be our input. I want to do it proper, so I'm gonna do it proper in the very beginning. Logic input, logic output. We got coffee, exactly. Sebas, you'll be fine, but do go to sleep right now. It'll make it so much easier for you. Okay, that's basically the first logic gate. Technically, I should also set up like the position vectors, but we'll get to that in a second. For now, let's just... let's make another logic gate. We're just gonna copy this, call it a NOT, and call this an AND. And the difference is that AND will have 2 cubes. You have epilepsy. Oh no. Then you should especially go to sleep then. Because you won't have coffee to wake you up. And one more cube. And then we want this cube to be a bit higher up, like 0.12, because why not? And then this one to be negative 0.12, like so. And then what we want is we want the two cylinders. We copied the wrong one. We want this one as well, and we want them to be at an angle, like this, a bit lower down, like this. Perfect. And then we're gonna have two logic inputs. Sweet and handy dandy. Logic, logic, and logic, and output. Perfect. Now we have the AND gate. Wait a second. Couldn't help but notice if I turn on the bottom one, it just works. That shouldn't happen. I see the issue. I plugged them in incorrectly. Perfect. We have the AND gate, and the OR gate will be really trivial to make, because for an OR gate all we need to do is just go and change the blue to, green to blue. Like this, and change this to an OR. Perfect, we have the logic gates. I haven't seen them for years. I still have migraines. That's really unfortunate. I'm so sorry. What now? Well, now what we need is connections between them, which means that I really should have done this with the logic gates themselves, because now it's gonna be a bit more annoying to implement. However, what we should basically do is create a separate geometry node for a cable. Actually, hold on. Creating a nice curve in Blender geometry nodes, because I don't want just a simple line. I've done it too many times. Let's do something a bit more, you know, sophisticated. Yeah, that's not what I want. So maybe. Huh. Huh. Then I could apply a curve to it. But that's actually really good. The only question is then how would I make the curve in the first place? Well, that's the question. I'm saying I'm gonna figure that out. Because we can create a curve using specific points, and then it would only be a matter of figuring those points out. Yeah, let's do it. So basically, we're gonna add two empties. Empty 1 and empty 2, and what we want is we want to create a really nice curve between them. So let's do it. Let's do a cylinder, because why not? Mesh line instance on points. And let's make group. Perfect. Now you're drinking coffee, Timon.
Yes, I'm sorry.
Right, for now let's just make the object follow this curve right here. And know that this we will just... So, wire... Know that this will just follow the geometry nodes, which means object info of this right here. We'll see what the fuck it does in a second. But then align Euler to vector, deprecated. Yeah, right. As if it could ever. Align another Euler to vector, this into rotation and this into vector. This time on the X. And then transform. And then what we want is we want to plug this into the rotation. I'm sorry. How does that work? Set position. Hold on. I must be getting confused about something. No, that's just... But... My computer just got really loud and I don't know why. When I started moving it, apparently something happened, but I don't know what. Hold on. So, basically... That is it. That is the end. Wait, what happens if I increase the file? Oh, Okay. No, that would be actually. Ah, fuck. Why is factor the? Damn it. What's the value change? The value change is nothing. Why is the factor gotta be the one that? Damn it. Because now I can't do it with an instance. I need to do it with the repeat. And the repeat is just less efficient than the instance. Yeah, let's repeat like 100 times, whatever. Plug this in right here. And then on each iteration, we just increase the factor math divide by 100. Well, there we have it, y'alls. There we have it. It follows a curve. I'll be. Well, I will just straight up be. Let's have an integer.
Really? Really?
What do you mean?
You will straight up be.
Yeah, when I
Yeah,
will be. I think.
highly doubt it.
I think
Highly
therefore.
doubt it. No, not the B part.
Took me a second to figure it out. Why is there a float there? What does this mean? You know what? I'm not even gonna question. Some version of using distance from its beginning. Oh, fine. Okay, the point is that right now we have a way to create like a wire, basically. The problem is it's kind of garbage. I mean, it doesn't look too bad from far away, I suppose. But the real issue is that we don't really have a way to match perfectly. How do you get the length of a curve? So can you get roots, fill, trim? Curve length. Well, that sure is simple. Curve length, and then so this is our full length. We divide it by amount of stuff, and then we fill that in as our depth, and that does not give us the correct answer because we didn't divide it by the amount of things. Okay, yeah, now it does give us the right answer, but there are still some yuckish geometries, but that's not really fixable, is it? Yeah. Now what are we to do? What are we to do? Well, what we are to do is we can subtract a certain amount from it, and we can add it back right here. And then this should count as the offset of our curve, if I'm not mistaken. Wow, I am good. I am just good at what I do. I don't know why they accumulate though, which is kind of worrying. Oh, because the length keeps increasing. No, that checks out. And we just want to add it back for... Yeah, the length, we just want the full thing. Full story. I messed it up. Whoops. Shucks. Oh, because I'm adding the wrong thing. Right. Yeah, no, that checks out. No, it doesn't. Hold on. Wait a minute. So... why do we divide it by the... Okay, so, like... we divide it by the amount that there will be. Oh yeah, because the amount we also want to be full. The only thing subtracted is we want the iterations, yes. But everything else... let me just plug this all back in. Just to make sure that it works for now. There we go. We have our curve. Now, if we... what we want to happen here is we want to deselect some of the original pieces. And in order to do that, we need to subtract them from the actual value of iterations. Now we're subtracting them from the end, which is not really what we want. We want from the beginning. And in order to subtract them from the beginning, we just need to add to the iteration. Well, that's neat. yeah, and then basically we're just gonna have a switch for floats that tells us if we're doing it from the end or from the beginning. I am good at what I do, that's incredible. And then at the end, the store named attribute, and it's just gonna be called bry, and then set material white, and then e-color gonna be, there we go. Perfect-ish, I think. I don't know. So the second will be sampling. Not sampling, only sampling. The first one will be offset. And then the third one, which will be a boolean, will be side. Then we're gonna have another boolean, actually. This, which will be the value boolean, like so. Going right here. And there we go. We have, and then one last thing, of course, which will be the curve. Now that we have this, we can do objects info, select the curve like this, value will be on, offset, reduce it, and there we go. We have a way to wrap a wire around the curve. Now only thing we need to do is figure out a way to make the curve. So interpolating curves in geometry nodes. We have our starting point, we have our end point. We want to interpolate it in some kind of yeah, will work. Okay, so here's my idea for how we'll do it. We will first of all make a group of this. We will have two objects as an input. Yes, we're gonna have two objects as an input, and those objects will be the things that we'll use to guide the animation. So for now, we want them to be this empty and this empty. And now that we go in there, we don't want geometry to be actually that. We want both of them to be relative, and we want the location between them. And here's what we're going to do. We're going to make a curve line between this point and this point. There we go. Then what we want to do is interpolate. Could it be just that easy? No, okay, hold on. How to interpolate the up vectors to be considered as normal. The positions of the first control was new generated interpolate curves. Wait, wasn't there like a to curve Mesh to curve. That's even better. That's because now we can do a mesh line. Like so. Where this will be the start location, this will be the end location. And it's going to have 5 in between them. Then we're gonna subdivide mesh. This is gonna end well, I can already tell. Let me just plug this into the outputs for a second. There we go. Then subdivision. Okay, subdivision 1 is already fine. Gotcha. Now what we want is we want first one right there, second one in the middle can be fine. But the way we will interpolate it is we will... It's gonna be fun. We will select the one with ID 1. So set position ID. Okay. Subtract 2 from it. Take absolute value. And also sign. And then compare with 1. So it's meant to be y. There we go. Now multiply. We're gonna have to multiply it twice. First we're gonna multiply by the sign. And then we're going to separate x, y, z on both of them. And then multiply it. Shit. And then we're gonna multiply it by its own respective thing. Actually, we don't need a sign in that case, do we? Well, we don't need it for this. We only needed to multiply this right here. Oh, but we need its own position subtracted from it, which means math subtract actually position and then separate x, y, z and the y. It's nothing. Okay, so we need the instance position subtracted. This is getting even more annoying. Okay, we can calculate that because it's a constant offset, which means we'll get to it in a minute. For now, all we need to do is take the sign, add 1 to it, divide by 2, plug this in, there we go. Okay, sweet. Now what we need to do is just subtract the original position from it. And to get there, what we'll need to do is it's really rough. This vector math plus divide by 5 this multiplied by 1. Alternatively, so if we right now separate xyz this, then one of them will be correct. We need to do it only for the ones that we actually care about, which is these ones. Which means that right here, this should be 0. Like this. That is not what I meant. Oh, because I subtracted from the wrong thing. Right, yes, okay, this is correct. Now... Oh yeah, because the bottom is what we want. Alright, yeah, that checks out, okay. Which means we don't actually need this. We can just plug this in directly because we already implemented a mix of our own. And what we actually want is we want to subtract it from here. Haha. And times 2 actually, and I'm pretty certain we just want to subtract right here and add on the other side, right? No. So very wrong. So very wrong. Okay, that's cool. No, I can figure this out. That's simple. Okay, what are you cooking? I'm trying to... Okay. I am trying to... Oh, but that's because I'm... Oh, shucks. I need to subdivide the mesh right here. Oh, that's not good. That's not good at all. I need to set the position before instancing them. Oh, thank goodness. I think I actually can. Oh, thank goodness. There we go. Perfect. That works. All right, so what we actually need to do is the multiplication by 2. That needs to happen on the bottom one. Right, so in this case, the bottom one is not accurate still. Why aren't you accurate? First one divided by 5. No, okay, no, that actually makes sense. That wouldn't be accurate. Wait, no, first one plus second one divided by 5. That should be accurate. No, it shouldn't be, because of the offset. Fuck! I can manage. Let's just focus on one of them for now. Just the top one. When I subtract the offset, what will the offset be? Well, it will be... We take one of the objects. Right. We imagine it as a vector in some direction. X, Y, yeah. Then we have another vector. Then what we want is we want this vector right here. In order to get that vector, we just... add their absolute values. No. That's their difference. The problem is, I need to pick the right one in order for it. So we'll have vector 1, vector 2. Vector 2 minus vector 1 gives us this. But then if this, we need to check which one is then the absolute value, right? Yes. You subtract. QWERTY, subtraction is not symmetric. Because subtraction is A minus B is effectively A plus minus B. And A plus minus B is not equal to minus A plus B. It's asymmetric. You can think of it like conjugate on one of these. And that's why I need to be careful about which vectors I'm subtracting, because the direction matters in this case. Which means I need to subtract them and not the absolute. This is a bitch. I like a charity work, by the way. Thank you, Sebas. Thank you. Thank you. No, it doesn't have to. Just multiply by 1. What? What should I multiply by 1? Okay, basically, if it's in the wrong order. Yeah, QWERTY, that's a phenomenal suggestion. How do I check if it's in the wrong order, though? Because I'm not gonna lie, I'm not gonna grill you. Considering how we have 2 3-dimensional vectors, correct me if I'm wrong, that means I would need to create a different thing depending on which one of those and in what combination they would be minuses. If you're gonna backseat logic me, at least do a good job. This vector this way would be a good way to do it. Moment can survival. I remember, Sebas. I didn't forget that fact. You already told before, and I remembered. Can't do money. It's fine. It's fine. I understand. I don't want to guilt anyone to donate charity either. Because I get it. Sometimes you just don't have the money to solve stuff. That's normal. Dot product, then take bigger one as second. But I would still need. But then I would still need to make 2 completely separate paths in geometry nodes with some pretty hefty math behind it. Also, wait, dot product with -1, 0, 0. I said that would work with 3 dimensions. Because that checks alignment with 1 dimension. So for example, what if we have 2 vectors like this? Does the dot product, or even better, or even better. Wait, does the dot product go cross? I think I'm misremembering products. Dot product this way, vector, ABC, XYZ. Crisscross applesauce. No, that's a cross product. Yeah. AX. No, yeah, that wouldn't work. Hold on. I'm just gonna double check my math just to make sure. Yeah, you have ABC dot XYZ is equal to AX plus BY plus CZ. The exact order doesn't matter because the point is that if our vectors right here are 0, 1, 0 and 0, -1, 0, then both of their dot products with -1, 0, 0, both of them would be just 0. In which case they're equal even though they're not. I'm about remembering which one uses trigonometry, dot product or cross product. Neither, they use multiplication. They're products. Other one uses the cosine function. Neither of them actually uses trigonometry. The cross gives you a vector. Well, yeah, the cross gives you a vector that's perpendicular with like it being dependent on the, but that's only if you're doing physics. If you're doing maths, then neither of them actually uses trigonometry.
Well, I don't think we ever use trigonometry in physics to get either cross product or dot product. Like that's a high school. I think that's high school mathematics when you use
Yeah,
trigonometry for these.
I do think that's only high school, because I mean there is no, the trigonometry is really like forced in there.
I mean, it can be like it can be useful. Like trigonometry can be important to know. It's just like you don't. It's just too complicated to use it when you don't have to.
Yeah, I mean there's a way to solve it using sums. Much easier. Back to the problem at hand. How do I make this work? How do I make this work? If I move one of them to the origin, however, then I just get the direction, and then I have to put it back. Oh yeah, thinking of vectors was nice. Why didn't make sense? It was forced. No, Sebastian. There is a way to make it make sense, but it's, how should I put this? There is a way in which it makes sense, but that's more like added in there as an explanation rather than like an inherent way for. Well, I mean, kind of in a way it's inherent. No, just don't worry about it. Trigonometry, neither of them actually use trigonometry. It's just that they can be calculated using trigonometry. Okay, so if we have our origin vector 1, vector 2, if we move a vector, one of the vectors to the origin, then one of them becomes 0, 0, and that's much easier, because then we get a clear line to the other vector. And as such, we either get this or we get this. And in that case, we can just take 1/5 of the distance either way, move 2/5 of the distance, and then put everything back. Which means what we would like to do is, I think I may be actually cooking, because yeah, right, you were just adding its own thing, and then what we want is to get some position. Subtract from the first vector, and then the first one becomes 0, 0. So this is our new second vector. First one is just 0, 0. Then this one we divide by 5. Then this one we multiply by 2. And then this one accounts for that amount of the way. So we add back in the vector we removed in the very beginning. And then we separate it off. Like so. Is it not a 2? Oh, it's a 4 and a 1. I am amazing. This appears to be working spot on. Hold on, let me just check. Yup. Okay, what if we flip them around? I am amazing. I am just truly amazing. Because if I'm not mistaken, then to the other one, I think if this is too simple, there's no way you can just add this, is there? Yeah, I knew it. It was too simple. But to the other one, all we have to do is switch the vectors. Or just multiply by 3. I think that should also work. Multiplied by 3. But this is more of a guess. There we go. I am just truly outstanding. Now, what we can do is we can reset it also on the other coordinate. Bye, Balin, bye, see ya. And in order to reset it on the other coordinate, we need to do the exact same thing, except that this time we're doing it right here. And as such, we want to set it to the middle this time. Is it asymmetric, by the way? It kind of seems to be, yeah, okay. Better not take any chances. This time, this one will tell us which to mix. And we want to mix the same exact thing except X, or am I wrong? I might be wrong. No, we don't want the same exact thing. We want it... Fudge sticks. This is trickier, because this time what we want is to set the X coordinate to the midpoint. However, we cannot really use the set position node, because if we do, then all of it will be much more difficult. Or maybe we should, actually. You know what? I take it back. Let's try it. Wait, no, combine. Basically, here's what we'll do. What we will do is we'll take ID and then we'll just do index switch, because I am really clever. Vectors. I'll put right here. There we go. And then the first one will be the first one. Last one will be the last one. Then vector math, just add them together. Divide by 2. That will be the midpoint. Perfection. My computer got real loud again. That's neat. And then for the two in between, we want to set the X coordinate to the same as the midpoint. We want the X coordinate to be the same. You know, vector math actually will be better, because we can multiply by 1 right here and then add like this and like this, but the y coordinates will be different because we will be adding to it the y coordinates. We'll have two separate additions like this. Okay, and now if we interpolate it, we get this. And now if we do curve to mesh, that isn't really getting interpolated, is it? Yeah, fudge. It means now what we actually want is we want to interpolate that curve. Which isn't really happening. Well, that's neat to know. We've made this, which generates us a curve, which is nice, but now how do I... And I go on to your can you make it stream in the afternoon so that I may watch? I'll try. I don't know. I'll try my best. Blender interpolates a curve in geometry nodes. What did you set up? Oh geez, that's mesh to curve. You instance on the mesh line being that, so that's not what you care about. The mesh to curve is already on the left. That's not what I'm looking for. Okay, fine. I guess we need this. The positions of the first root control points of newly generated interpolate curve. Okay, so we have... Wait, I'm fine. The positions of the first root control points. Could I has an example? How do you interpolate curves? Oh, what now? Oh, what now? Oh, absolutely what now? I have no idea how that works. Whoops. Hi, the Theo. Hi.
Hi.
Oh! I've done it. Well, kind of. Like, the distance is it's gonna be a bit tricky to mimic, but I mean... I've done it-ish. Limit radius. I am incredible! Wow! Look at that! My blender is not liking me moving this, but I can move it at the very least. Ain't that just something? Which means that now, what we can do is... just finish it all up. Can it branch? It doesn't really need to branch, because I mean, a branch is just two of them. Two of them is just a branch. There we go. And then like boolean. Perfect. Perfect, perfect, perfect. This will look really nicely. The now the last thing to do would be to... Yeah, I would like to do it with guiding empties, because that's much nicer. The problem is that we can't really have guiding empties when it comes to this generation. In this case, we do want the... Oh, fuck. We do want the vectors. Perfect. Now let me just remove... Now to remove only... Switch to a vector, which we plug in here. Actually, no, wait. What am I doing? Just plug it in directly. This is usually where things break. There we go. Now right here we can do object info. Relative on all of them. I guess in this case we like the 0 and this. Like so. Make the corners stop changing radius. Why? Alright, and now what we want is for each of these to also get the... Okay, so basically, this is where the trickiness comes into play, because depending on the logic gate, it will have different positions of the inputs. The outputs will be constant, the inputs will not, which means what we need is we'll actually need another node that will be... Let's call it generate curve. We'll need another node that will be like capture location, in which case we select the input and it captures that location of the node, which will be a pretty simple node actually. So right here, let's just join in our or, and let's join in our not, because why not? And what we'll have is we'll have a simple circuit in which we have two inputs going into our OR gate, and then we're gonna have it go into a NOT gate. Simple as it could be. That's all it's gonna do. Oh, actually, if they are on a single line, that might screw them up a bit. I didn't think of that. On a single line on the y-axis, that might screw them up a lot. Manageable. Okay, Blender, I'm glad you're handling this with with care. Okay, so now how we're gonna do it? Well, that's simple. We will add in to all of these after them. Okay, I'll think about it in a second. For now, let's just do it. We'll have in 0, in 1, or, and then not, and then out, like this. Then what we want is we want our or, the location of or. Perfect. And increase the size a bit, I suppose. Well, actually, no, we shouldn't increase the size. Yeah. What we should actually do is we should bring all of these closer in, and we should just change the wire to be less thick. Perfect. Then our NOT gate, we want to be at NOT. Perfect again. And then let's move it a little bit lower down, because why not? And then what we want is this, by the way, we'd like also to output the value that's going in. Just because it will make things a bit easier. And then third and fourth wire. First, we're gonna have in 0, in 1, then or, then not, then out. What about a NOT gate? Alright, there we go, and there we go. Yeah, it looks really weird if they're barely on a different height, but if they're on the same height, it's getting really close to a divide by 0 problem. And then we need the fix-em-ups. So new node, which will be vector muff, and it will be just a simple addition, as simple as it could be. Make group. It will just take in one vector and will output 3. Now here's how it's gonna work. We're gonna take this and we're gonna use right here the first one, then right here the second one, and we're gonna use them to align our vectors, simple as it could be. So right here we do y a bit whoops. Start. No, we don't want to. I'm in the starting point. I'm an idiot. I'm gonna do this. Right, yes. Okay, now. Negative 0.4. And then. Perfect. The Z is gonna be a bit tricky because the Z is messed up. So we'll just push all of the logic gates down. Yeah, that's a good idea. There we go. So then I imagine the next one will be the same exact thing, except like this. Oh yeah, and then one last would be the output, but that's for later. Then right here, I imagine will be the same exact thing, except in the middle. And actually, I imagine this would be the same exact thing, except the other side. And so now what we can do is we can just make it. I understand why you want to move to the Netherlands. I'd rather. Now what we want is we want this curve, which is the output, to not stem from the OR, only output OR, which means right here we're gonna have in left, in center, in right, and then output. There we go. From output to the input center of the red one. And then from output, that's not what I meant. And then from output to just that place. And now the last thing, which is we start with some kind of value on these two. These two get plugged into an OR gate, which gets plugged into this one, which gets plugged into the NOT gate, which gets plugged into this one. And now there we have it, everyone. We have, isn't that rather neat and sweet that we basically can make logic circuits in Blender and just move them around as well. I do have to say, this is much better than my previous ones. Hot shit. Thank you, Theo. Finally. Thank you, Theo. Finally, someone appreciates it. No, that's the bulk of the job done. Now the only thing left would be to clean it up so that basically it would, be much easier to operate with. So I imagine we just combine all of these in so that you can select just the node and select the basically. Can you have as an input actually a menu? I imagine you can. Menu. How do you edit the menu? Menu switch? I guess I can just use it this way. Yep. I guess we can just use it this way.
Hi, Macaroni.
Hi.
Hi there. Alright, so now all we need to do is just, as I mentioned, clean it up. So, every single logic gate will have its own corresponding output, which means that the way we'll actually group them is we will take these. Oh, this is going to be rough. We'll have the updated geometry node option, and here's how it's going to work. Oh, piss. There we go, that's the make it all piss moment. You're all welcome. We're gonna have test 0 and we're gonna have test 1, and basically we're gonna take these nodes. Let me just make a copy just in case. We're gonna take these nodes. Here's our logic gates. Here's our creator of Y's, and then we're gonna delete all of these. We don't need them anymore. join, and basically we'll have this. Make group.
Immoral. That is because no one ever like it. There isn't so much lore. Like I used to have the correct IPA pronunciation of my name in my name, and people still kept on pronouncing it the way Make It did, even though that's only Make It's privilege to mispronounce my name. So yeah, I just renamed myself.
Okay.
Immoral asked a question. I'm just answering that.
I mean, like it's a pretty unusual name.
I know that's why I had the IPA in my
Yeah,
name.
I get, but like, not everybody looks at it fully, you know. I know some people don't actually dig into every detail of everything.
I know, but like I don't know. It was still like even the people to whom I thought that that's not how my name is pronounced kept like, come on.
Damn. Damn.
I just had to.
Because only make it can, like physically possible, only make it to make it. Exactly. Location right here. Muff.
Need to print me that helmet.
And right here we can actually add more complicated components. Well, if we do it right, which, I mean, eventually we're gonna add more complicated components to this. These will be really funky, in fact. Geometry nodes.
I know Immoral, but like it was in my name. Like whenever you see me text, you can see it. And those other people pronounce it correctly, so
Are you sure?
Don't start with this
well,
again.
most people.
I had a bit too much brain rot yesterday.
Oh, what am I doing? This is never gonna be connected to output. That's idiotic. Just, there we go. Perfect. Now this right here, and then its location should be output, and then output locator, like so, and then this in here.
Fix.
I don't know how to answer that question.
That is going in the best comments. No doubt about that. Yep.
What?
That is going into the best comments, and I'm not questioning it 1 second more.
Oh, we're in live voice channel. I forgot.
Yeah, it's stream. What do you mean?
Bro, I just woke up. Okay. I don't have that kind of awareness.
Oh, this menu ain't gonna work, is it? Oh, that's really a bit of a pickle, because I would have really liked for it to work. Would have been quite nice.
Theo is in fact correct.
Do I really need to just add another one? Because that's dumb. I don't like it. I need to just have 2 of them for no reason. Gates again. Yeah, festive. Cool. I think. Is this good? Should be. Alright, well, let's see. Oh yeah, because that's where we should end, and we should begin right here at the out. Perfection. Now what we can do is also go in and take the output as the output. Perfect. And then actually join geometry and just add geometry as an input. And now we can just chain link however many of these we want. Can I have the geometry input as like multiple things? Because not gonna lie, that would be just really sweet. I guess it's gonna be 2 anyway. I just found an issue with my solution, but nothing too unfixable. All we need to do is just add in 1 more geometry. That will be just straight up nothing, I think, at the very least. Therefore I am. Like this, and then oh yeah, right. Between this and that, we'll need to select which input we want from a gate. Because that will determine... Oh no, the names are just screwed up, that's it. Never mind. That will be Why did I call it left, center, right when it's not? Whatever. Center. Bottom. Okay, so now, using these, we should be able to make, in fact, should be able to put this one right here, set it to be an OR gate, set this one to be the bottom input, then the input will go like this, there we go, and then the output will go towards this one, because why not? Although we should also have a switch that actually says if the output should be a thing or it shouldn't be a thing. There we go. Look at this absolute beauty. Oh fuck, I turned everything off, not what I just wanted. I meant this, because this is the output. There we go. Now look at this absolute beauty of a geometry node setup. I mean, this is just phenomenal. There we go. Now disable output. Perfect. And then the bottom one will be another one right here. Like this. Ah, shucks. It just hit me. Okay, so we need actually... Okay. No, I see problem. I see the problem. We need this and this separately. Yeah, we can delete this now. There we go. And then the output. Yeah, I see the pickle. We need to plug the... Oh, fuck. We need to plug all the gates like this. I really should find a cleaner way to do it. And then we're gonna need to plug in the wires separately, like so. Yes. Delete this one for now. There we go. Now I really need to find a cleaner way to connect the geometry. Output, for example, that only has group output, which sucks. Is there a way for me to by default somehow connect it to the output? I don't think there is. I think the only way to do it would be just have it there. Question: I have multiple geometries selected. May I just add them all in? Or is that illegal? That seems to be illegal. Yeah, that sucks. That just sucks. Okay, fine. We'll do it this way for now. Maybe I'll find something cleaner later on. Output, then the two knots on the very beginning to this output as well. It being U, come on, U right here. We want Oh yeah, because no. We cannot double our outputs either. So instead we need to generate new ones. This time they will be geometry, so they will be just non-existent. And we plug in the inputs right here. Hi there, Remco. Hi, welcome.
Hi. Ah, my. Hi.
And then what we do is we plug in this. Output being right here. Failed to find null. This is a good sign. And certainly not just my Blender absolutely breaking. There we go. I think that's it. Now, if I'm not mistaken, if we select the top, if we select the bottom, the top and the bottom, then isn't that pretty neat? Well, isn't that just pretty neat? We have, in fact, created... That's it, that's the full setup. And look how clean this geometry now. Well, clean-ish. This still have, like, a fair bit of junk, but... Basically, we need one geometry node per connection. That's what we need. Technically, it's one geometry node per gate, except there are some invisible gates we just simply don't use. But if only I could find a better way to handle multiple inputs, multiple outputs, that would solve my issues. I guess I could do it with... If I wanted to be really clean, I could just include the geometry. I could just include a mesh as my outputs, and then I could just have a repeat node which repeats over all of them. And that would then be really clean. But to be fair, then we would need to also like include the data of whenever it should be a top, middle, or a bottom. And then it gets really tricky. We could just have a store attribute, I guess. That would be really advanced. We could do it though. Top, middle, bottom forks. No, it's piss off with that. We've done it. We have a basic setup. There we have it. Cool. Now we can now we can make logic circuits. If anything, one thing I could do is I could actually include one additional value here, which will be the value of between, actually, I would like to carry over it being between 1 and 0. Because then, inside our wire, right here, integer. The same one goes, the sampling will go right here. And there we go. Oh, all of these are set to a half. Why? Just set them to a 1. There we go. Yeah, this one doesn't matter because this one doesn't actually have an output. And then another thing this could control is it could control the position of our gate right here, which means we could add, separate XY, no, combine XYZ. And now basically whenever we create a gate, what we would do is we would... Actually no, this is kind of garbage, I don't like it. I don't like it. Let's remove it. We just create a gate and then make a connection between them. Neat! Alright. Proszę mention when Momentum DLC dropping. Momentum's too much. We ain't doing Momentum. Anyhow, I think that'll be it. We've done a fair bit of work today. We've set up the geometry nodes for the videos, which I'll use. I will need to go and work on the script now for the video to then, you know, make the CPU and junk. I guess that'll be it. And for now, I suppose that'll be it. Thank you everyone so much for watching and have a great day.